third graders. So we are going to continue reviewing our Module 3 math concepts. So before we went off to winter break, we were talking about different multiples, 6, 7, 8, 9. We were talking about the distributive property, associative property. We talked about units and all, and what each unit means. So we're going to just keep on going with this review for our test on Friday. All right, so imagine that I cut out part of a multiplication chart, okay? So I cut out maybe the bottom right corner of it where I only have the 6s, the 7s, the 8s, and the 9s, okay? So if you can see that on my screen. So the way that you solve one of these types of problems, the easiest way that I find, because it can look a little overwhelming when you're first looking at it, I look at my 6s first. So I'll just pick one column and maybe it's my 6s, okay? So I see how some of my 6s are filled in and some are missing. So this X right here tells you that you're multiplying. So you have 7 times 6 in order to find what's in this missing square right here, okay? So we have 6 times 6, which is 36. But then we're missing the next number. Remember, when we're skip counting by 6s, we're adding 6 every single time, okay? So right here, I want you to fill in what that missing number would be. So we have 36, now it's 36 plus 6, or what is 6 times 7? Good, the answer is 42. Now, again, I'm going to continue with my 6s. So my whole column of 6s is filled in. That's awesome. Now I'm going to fill in the rest of my row of 6s. All right. So right here, I have 6 times 6, 36. And then I have 6 times 7 in order to get this missing one. Well, didn't we just do 6 times 7 over here? We did. So what is the answer that goes in for 6 times 7 or 7 times 6? Good. We have 42 again. Now we're going to keep going. So we're going to keep on skip counting by 6s, okay? It's like we're kind of starting in the middle of the list of 6s, and we're just going to keep going. So we have 36. 36 plus 6, 42. 42 plus 6 will give you your 8 times 6, okay? So 6 times 8, what goes in this box? We're adding 6. Good, 48. All right, so now I have my 6s done. I have my column of 6s completed, and I have my row of 6s completed. So now let's go to my 7s. So I have my column of 7s that is right here, and then I have my row of 7s, all right? So we are going to keep on filling this in. So I'm going to go to my column right here of 7. So I have 42, 49. Now what comes next? So for 8 times 7, I need this box filled in. So if I do 8 times 7, what is that missing number? We're going to skip count by 7. So 42, 42 plus 7, 49. 49 plus 7 is, oh, it's over here. Okay, so we have actually, so let me go back a little bit. Okay, so for 7 times 9, we have 63 over here. So I filled in this row of 7s first. So now we're going to do, what is 8 times 7? I gave you that one for free. Good, we have 56, okay? All right, so my 7s are completed. I have my row of 7s done. I have my column of 7s done. Now I'm gonna go to my 8s. All right, so I have my row of 8s right here, and then I have my column of 8s right here. All right, so for my 8s, I see that this one is our next one. So I have 48. What's 48? Since I'm doing skip counting by 8s, I add 8 every time. So 48 plus 8, 56. 56 plus 8 is 64. All right, now my row of 8s is done, but I just need to do this one last one right here for my column of 8s, okay? So I have 9 times 8. 9 times 8 is, or you can just add 8. So you can do 48 plus 8. 56. 56 plus 8, 64. 64 plus 8 is 72. And now we only have one left. So that way, when you do your 6s and then your 7s and then your 8s, by the time you get to the bigger and bigger numbers, you have less ones to do because the chart is slowly being filled in. So I have 9 times 9. So I have 54 plus 9, 63 plus 9, 72. 72 plus 9 is 81. So we have just filled out the missing pieces of our multiplication chart. Make sure that you practice skip counting by 6s, 7s, 8s, and 9s. Okay, so for this one, it says, don't forget that these are called parentheses. They look like little half circles, okay? So your parentheses are right here. It's this little punctuation mark right here and a little punctuation mark right here. When we use parentheses in math, it means that we must solve whatever is inside the parentheses first. Okay, so no matter what's inside your parentheses, that's the first thing you solve. So try these two problems and select your answer. So we have 2 plus 2 plus 6. Well, then we saw that when we did what was inside the parentheses first, we got 4. Okay, and then we just brought down what was left over. The plus 6 is just still chilling out. It's on the side. So now we have 4 plus 6. 4 plus 6 is 10. In the next problem, we have 2 plus, and then what's inside the parentheses? 2 plus 6. So since we have 2 plus 6 that's inside the parentheses first, we must do that first. So 2 plus 6 is 8, okay? And then we have the plus 2 hanging out on the side. So 2 plus 8 is 10. Well, what happened when there's only addition in our math problems? The answer stayed the same. So you see how we got 10 for both of those answers? Even when we move the parentheses around, we got 10 because we only did addition in that equation. If we do multiplication or division or subtraction with addition, or if you did subtraction and division or multiplication division, okay, once you get more than one type of math involved, that's when the parentheses become very important. So let's see what that would look like. All right, so we have these two problems. All right, so we have 2 times 2 plus 6. Okay, so again, inside the parentheses, 2 times 2 is 4. And then we have the plus 6 on the side, just that's what's left over, all right? So we have 4 plus 6, that's 10. Okay, easy enough. Now what happens? So I move my parentheses, okay? I have multiplication and addition in this one, just like the one up here, multiplication and division. So I move my parentheses, and what happened? Well, first, solve what's inside. So 2 plus 6 is 8, okay? And then you just drop down whatever is left over that was outside your parentheses, which is the 2 times, all right? So we have 2 times 8. What's 2 times 8? 16. So what happened when you had multiplication and addition inside with your parentheses? The answers changed. The parentheses reminded you that you must do what's inside first, especially when you see more than one type of math symbol in an equation. Okay, so we are going to be using cube values to solve problems. All right, so you know how different dollars have different values. All right, in math, we can have objects represent the same thing. So if you have a $1 bill, it's just simply $1. Okay, that $1 bill is $1. However, if you have a $100 bill, just only one of them, you have one $100 bill, that actually means it has a value of 100. So we, for example, with cubes, we'll take 3 cubes. What's the value of your cubes? 3. You only have 3 cubes. The value of your cubes is 3. Okay, 3 cubes, 3. Now, what if we said that 1 cube actually has a value of 2? Like what I said with the dollar bills above, okay? So if we had 1 cube that had a value of 2, you would no longer have the value of 3 cubes, but it would be 3 groups of 2, or 3 times 2, which is 6. So do you see how on this chart right here, do you see how on this chart right here, we have the 2 and the 2 and the 2? So I don't have just 3 boxes. I actually have 3 boxes, but each one has a value of 2. So I figured out that 3 groups of 2 is 6. All right, so you can try this on your own. Okay, so if I have 2 cubes and each cube has a value of 6, what's my value? So I have 2 groups of 6, okay? So my 2 cubes, they both represent 6 and 6. So if I have 2 groups of 6, 12, okay? And the next one, if I have 5 cubes, and each of those 5 cubes has a value of 3. So we have 3, 3, 3, 3, 3. Okay. I have 5 groups of 3. So 5 times 3 is 15. All right. So that is it for today's review. Make sure you come back tomorrow to get your final day of review so that you can be ready to go for our test on Friday. Hello, friends, and welcome to day 2 of our math review. So this is our last day of the math review. If you want, you can always go back into your Edpuzzle and review the videos that Mr. Koenig and I made for you so that you can be prepared for tomorrow's math test. Okay, so today's video will be a little shorter than yesterday because we just have 2 things to cover today. So we are understanding odd and even numbers. All right, so I've included a picture over here. So look at that picture as you listen to what I'm saying. Even numbers always end with a digit of 0, 2, 4, 6, or 8. All right, so look at that list underneath. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. They're all even numbers. Why? Because at the end of every number, it has a 0, a 2, a 4, a 6, or an 8. So a 2, a 4, 6, 8. And then we start over again. 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Okay? Odd numbers always end with a digit of 1, 3, 5, 7, or 9. Okay, so kind of similar to what I said above. It's just our odd numbers are a little different. Our odd numbers end with a 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. 1, 3, 5, 7, 9, 31. Okay, they're all odd numbers. So if you look at the picture to the right, the orange numbers are odd. So if you see these columns in orange, these are all our odd numbers. So look, 1, 1, 1, 1, 1, 1. See how these numbers all end with a 1? And what about here in the ones place? We have a 3, a 3, a 3, a 3. And then 5s, 5, 5, 5, 5, 7s, and our 9s. Okay, and then looking over at our even numbers, same thing. So our even numbers, like we said, it's a 0, 2, 4, 6, or 8. So I have 2s, my numbers ending in 2s, 4s, 6s, and so on. So good review from 2nd grade. Okay, so we are going to watch part of this video to help you understand multiplying by multiples of 10 and understanding the use of place value to solve the problems.
And we are going to continue to look at the number 30 since it is a multiple of 10. We can say that 30 is equal to the number 10 times 3. Or in terms of money, we can think of $30 as 3 $10 bills. We're going to continue to look at the number 30 since it is a multiple of 10. We can say that 30 is equal to the number 10 times 3. Or in terms of money, we can think of $30 as 3 $10 bills. So we can continue to extend our thinking here to the idea of place values. 30 is a 3 with 1 0 digit, and we can think of it as 3 times 10. 300 is a 3 with 2 0 digits, and we can think of it as 3 times 100. 3,000 is a 3 with 3 0 digits, and we can think of it as 3 times 1,000. So we can see how the place values, in this case the 0 digits, correspond. Cool. So let's go ahead and start our first example where we want to multiply 17 times 10. Now, we can think of this as laying out 17 $10 bills and figuring out how much money that would be. So 17 tens would equal 170. Now, what if we were to replace that 10 with a 20? So now we have 17 times 20. Now, instead of 17 piles of 10, we have 17 piles of 2 tens, since 2 tens equals 20. So we can rethink this product as 17 times 2 tens, since 20 and 2 tens are equivalent. And 17 times 2 tens is 34 tens, and 17 times 2 is 34, and 34 $10 bills would be $340.
Oh, yeah!
For our next example, we want to find the product of 40 and 5. Now we're going to rewrite 40 as 4 tens, and again we want to multiply this by 5. So 4 times 5, in this case 4 tens times 5, would equal 20 tens. And 20 times 10, or 20 $10 bills, would equal 200. Now there is another trick that we can use here when multiplying with multiples of 10. What we're going to do is take the two non-zero digits and multiply them together. In this case, 4 times 5, which equals 20. And then notice that 40, which is our multiple of 10, has 1 0 digit. So we'll take that 1 0 digit and tack it onto the product that we just found. And a 20 with an extra 0 added to it is 200.
Ooh.
So either method will get you the same product. So with this